from break. I hope everybody had a nice break. And it was relaxing. You did everything you wanted, got everything you wanted, and it was just wonderful. But we got to get back into the swing of things. So we're going to start a unit called balancing and reactions. So this unit, we're going to be basically counting atoms and then figuring out how many we start with, how many we end with, and that number always needs to be the same. So before we can learn how to do that, first we need to figure out how to count the number of atoms that are in a reaction. So the whole theme of this unit are chemical reactions. And chemical reactions is when one or more substances changes into a new substance. So it's things like you start with something and you end up with something that's completely different. So a chemical reaction is completely different than a physical reaction. So physical reaction or a physical change is when something starts as something in one form and changes into the same thing in a different form. So that would be like ice melting into water, right? And when ice turns into water, they're both H2O. So there's no chemical change there. Or if you heat up water and boil it into water vapor, it's still water. It's just had a chemical change. A chemical reaction is something where you start with something like hydrogen and oxygen, and you combine them to make water. You have two different substances to combine to make a new substance. So these reactions consist of things called reactants and products. And reactants are the beginning substances before a chemical change. So they are the things that react with one another. And these are going to be always going to be written to the left of the arrow in a chemical reaction. So if we look at this little example right here, H2 and O2, hydrogen and oxygen, these are the reactants because these are the two things that are going to react together to form something new. So these are the things that react. Okay. Products, these are the substances that are formed after a chemical change. So products are the things that are produced. And these are going to occur to the right of the arrow in a chemical reaction. So if we're looking at this right here, these are our reactants. They reacted to produce water, which is our product. So it's the thing that's produced. Okay. Now, in all chemical reactions, the number of atoms of each element is conserved, right? Because we know that is the law of conservation of matter, which you guys learned first semester. You should have learned first semester. Means that all matter that is here is always here. It starts here, it ends here, but the thing that can happen is that it can change. So for us in this unit, that means that the number of atoms before must equal the number of atoms after. And it's specifically atoms, not molecules. Okay. So for example, an atom would be something like carbon. A molecule is something like CO3, right? This is a molecule which is made up of many atoms. An atom is just a singular atom. Now, in order to be able to ensure that all atoms are conserved, the first thing we have to do is something called an atom inventory. And the word inventory means to count. So we're literally going to be counting atoms. So first thing we have to do under the arrow of the chemical reaction, we need to write each atom from the chemical reaction in list form. So for example, if I look at this reaction right here, we have Cu plus AgNO3, copper plus silver nitrate, reacts to form silver and copper nitrate. So these are our reactants, and these are our products. Okay, now in order to do the atom inventory, like I said, under the arrow of the chemical reaction, we're going to write each atom from the chemical reaction in list form. But there is a but. But if there is a polyatomic involved, so polyatomics, remember, anything from this part of the periodic table, we need to write it as such unless it is not present on both sides of the equation. So here's our example problem. Refocus. So the first atom, and what you want to do is you always want to start on the left side of the arrow and only count what you see on the left side. So first thing that we have is Cu. So under the arrow, I'm going to write my first atom, which is Cu. Next, we have Ag, silver. And then next, we come across a polyatomic, which is NO3. Now, what we need to do is we need to check to make sure it's on both sides. So NO3 is right here. Is NO3 in the exact same form on the other side? Yes. So what we're going to do here in our list is I'm going to put a parentheses around NO3 because NO3 is always NO3. I have to write it exactly as it appears on my periodic table. And it's in parentheses on this side. So if you see it in parentheses, stick it in parentheses. Okay, so I've made my list of the atoms that exist. I don't need to repeat the ones that are on this side because I've already listed all of them from the left. All right, now on the left side of the atom list, we're going to write the number of each atom that is present on the reactant side. So if I look here, how many coppers are right here? Since there's no subscript, there's only one copper. Right here, I have silver nitrate. Now, silver has no subscript, so that means there's one silver. Nitrate, there are no parentheses around it, like that, okay? So if there are no parentheses around it and there are no numbers outside of that parentheses, that means we only have one NO3. All right, so I counted the number that's on the reactant side. Now I need to count the number that's on the product side. So here, silver. Silver does not have any subscripts, so silver is going to get a 1, since there's only one. Copper has no subscripts, so that means there's only one copper. Now this nitrate right here, NO3, it does have parentheses and it does have a subscript. So how many nitrates are there? There are 2. All right, so I've counted the number of atoms that are on both sides. That's how you do the inventory. That's it. All right, we're going to do next 2 inventories. But before we do that, I'm going to stick this on because the glare is pretty bad. Hold on. Still here. Still here. All right. That's a little bit better. Okay. All right. Atom inventory for the next set. All right. So let's write our list of atoms. We have Au2. So gold sulfide. So the first atom I have is Au. Then I have sulfur. Then I have hydrogen. Now I don't need to keep writing because I've already listed gold. I've already listed hydrogen. I've already listed sulfur. So I'm going to count the number of atoms that are on my reactant side. Right here, Au has a subscript of 2, so I'm going to put a 2. Sulfur has a subscript of 3, which means there are 3 sulfurs on this side. And hydrogen has a subscript of 2, so I'm going to put a 2 next to hydrogen. On the product side, there are no subscripts with gold, so there's 1. For hydrogen, there's a subscript of 2 for hydrogen, so that means there's 2 hydrogen. And there are no subscripts next to sulfur, so that means there's just 1 sulfur. There we go. That's how you do your atom inventory. You count, you write how many are on each side, and then you move on. All right, and last but not least, we have these compounds here. Okay, so what's my first atom? Sodium. My next atom is silicon. And then my next atom is fluorine. Now, sodium is listed again. So do you think I need to list sodium again? No, I'm not going to list sodium again, but I'm going to count the sodium with the number of sodiums that are here and write that in my list. All right, so sodium, there are 2 here. There's 1 here. How many total are on this side? There are 3. 2 plus 1 is 3. Silicon, how many silicons are right here? It has no subscript, so there's 1. Fluorines, how many fluorines are right here? There are 6, so I'm going to write a 6. Moving on to the next side, silicon, there's 1. Sodium, no subscripts, there's 1. And fluorine, no subscripts, there's also 1. All right, so what you guys are going to do is you are going to do just the atom inventories for worksheets number 1 and 2. That shouldn't take you very long. I'm going to do another example. I'll do an example right here to show you how a polyatomic could be on one side, but not on the other. I have to find one somewhere. Let's see. Oh, no, I don't want to do that one. Let's see. I'll find one somewhere. Okay, perfect. Here's an example. Okay, so if you go to worksheet number 2, which you guys have to do, and you go to number 12 on worksheet number 2, we're going to do the atom inventory for this problem. We have calcium carbonate, SO2, sodium dioxide, oxygen, creates calcium sulfate and carbon dioxide. So first atom in my list is Ca. All right, now here's a polyatomic, CO3. Since there's a polyatomic, I'm going to put parentheses around it, right? But what I have to do is I have to check to make sure that CO3, as it exists right here, is on both sides. I have CO3 here, but I have CO2 over here. This is carbonate. This is carbon dioxide. They are not the same substance, so I cannot keep CO3 together in my atom inventory. I have to separate the C and the O because CO3 and CO2 are not the same thing. So in my list, I'm going to write C, and I'm going to write O, and then I'm going to move on. Okay, next I come across SO2. SO2 is not a polyatomic. It does not exist in this list here. This is sodium, or sulfur dioxide. But the polyatomic SO4, which is sulfate, is right here. These are two different substances. I cannot write SO4 in my list because SO4 is the polyatomic, SO2 is not. So what do I have to do with these atoms? I can't write them together in my list, so I have to separate them. So I'm going to write S, and then I have to separate O, but I'm not going to write O again because O I've already written from CO3. So the next atom is O. I'm going to leave it. It's already in my list. So let's count how many of each we have on each side. So calcium. On my reactant side, there's 1 calcium. Carbon, there's 1 carbon right here, 1 carbon. Now oxygen, let's count how many oxygens we have. We have 3 oxygens plus 2 oxygens, that's 5, plus another 2 oxygens, so 3 plus 2, that's 5, plus 2, there are 7 oxygens on this side. And then sulfur is my last one. There's no subscripts with sulfur, so there's just 1. On my product side, I have 1 calcium. Carbon, there's 1. There's no subscript with carbon, so there's 1. Oxygen, I have 4 right here and 2 right here. 4 plus 2 is 6. And sulfur, there's 1 sulfur. So that's my atom inventory for this reaction. All right, so start on your atom inventories for worksheets number 1 and 2, and then you can move on.